So if you have, let's say 1 over 10, like firstly, we know that if you have 10 alone, like 10x, 10x can be written as sine x over cos x. You see, the fortunate thing is if this 10x is under a 1, if you have 1 over 10x, 1 over 10x can be written as cos x over sine x. You see, that's like a fact.
So you tip in times, okay.
Yeah, yes, 100%. Because look, 1 over 1 is just like 1 over 1, right? Divided by 10x, you can have the no. Divided by 10x, right? It's gonna be you dividing by sine x over cos x, of which you can tip in times, as you said, flip it over, and then you can see that, okay, fine, it's just cos x over sine x. That's why from here you can just go straight here. From here you can just go straight over there. Now, if this is squared, these have to be squared. If this is squared, these have to be squared. Do you get it?
Oh, okay.
Yeah. So what that means is automatically, right, from the get-go, like automatically from the get-go, you need to, what you may call, you need to keep in mind certain things, right? From the get-go, you need to keep in mind that while we have here 1 over 10 squared x, right? So let's say here 1, where you see 1 over 10 squared x, we can just change it automatically to, let's just state we're working on the left-hand side, right? On the left-hand side, we're gonna change this thing to cos squared x over sine squared x minus cos squared x, right? Minus cos squared x. This is over 1. You may want to put this over 1 because this is a fraction. And the fortunate thing is this is slightly going to be a bit straightforward for us because we want to have an LCD, right? So here we'll probably multiply by sine squared x over sine squared x. Whoa, what's going on here? Ran out of space is what happened. I don't know, I'm writing so big though. Like, bro, what is the world? Let me just try and get some space here. So times sine squared x over sine squared x. So you're gonna have here cos squared x minus this times this is gonna give you cos squared x times sine squared x, right? The whole thing over sine squared x. Now the fortunate thing is this is where you just have to be a little bit creative, because remember your job is to try and make this look like that. So automatically you should be thinking to yourself, okay, fine, based on what you have so far, right? You want the top to only have cos, you see, but so far you have a cos with the sine. It's just like, you know, it's just like a whole mess. So what you can do for yourself is clearly here you can see that you can take out cos as a common factor at the top here. So at the top, you can have the cos squared out. Then here you have 1 minus sine squared x. The bottom here, you have sine squared x. Do you see?
I see.
Yeah. Now this is where, again, something to do with trigonometry comes into play, the square identity. This here, you can change it to cos squared x, because remember we stated that sine squared x plus cos squared x, this is always equal to 1. Now, you're always able to rearrange this depending on what works for you. Meaning, if you want to have sine on its own, right? Sine squared can be put on its own, meaning this goes over. It's equal to 1 minus cos squared x. Meaning, if you see something like this, you can write it like this. If you see something like this, you can write it like that. Another way is if you leave the cos on the one side, so let's leave the cos squared x here, cos squared x. If the cos squared x is here, right here, you're going to have 1 minus sine squared x. Do you get it?
Yeah, I see. Yeah.
Yeah. So with all this being said, right? With all this being said, what do we need? We can say here where we see the 1 minus sine squared x, right? We can immediately write it as cos squared x. So meaning at the top here, we have cos squared x multiplied by another cos squared x The whole thing here is sine squared x at the bottom, right? So cos squared x times cos squared x is giving us cos to the power of 4 x, like that. And then you can say here, therefore, left-hand side is equal to right-hand side. And then you're done.
Oh, okay. So I kind of complicated it. Thank you.
Yeah, well, you are is welcome. You are is welcome. I forgot how to